Hello everyone, welcome to another video for mathematics of grade 10. In this video, we are going to solve some of the exercises of chapter 7, section 6, which is about circles in coordinates plane. In previous video, we covered the study of circles in coordinates plane. I gave you the general and a standard equation of a circle. And we did a couple of examples in that video. Now we are going to solve some more exercises from the same topic. Okay, so the first question goes like this. Find the center and radius of the circle of this one. So this question is easy because the equation that you see here is in a standard form. So we can easily read off the center and radius from this equation. So let's review the equation in a standard form. So remember, the equation in a standard form was given by x minus a squared plus y minus b squared equals r squared. So now if you compare this general equation with this given one, you can easily find out that the center is, so the center is 4, its x coordinate is 4, and its y coordinate is negative 3. Okay, so and what is the radius? This 11 here is r squared, so r squared is 11, which means r is root 11, and that's it. Second question says, write the equation of a circle whose center is at 3 and 6 and its radius is root 5. So this question is kind of opposite to the first one. In the first one, you were given the equation and you were asked to find the center and radius. Here, you're given center and radius, and now you're going to write back the equation. So let's do that. The equation is given by x minus a squared plus y minus b squared equals r squared. So now let's replace. A is 3 and b is 6 here, and that's the radius. So let's just replace here. X minus 3 squared plus y minus 6 squared equals r squared. So root 5 squared is just 5. And that's the equation. Okay. Next question. Number 3. Find center and radius of the circle, which is given by this equation over here. So as you see here, this equation is not in a standard form. It's an expanded form, so we have to turn this back into the general and standard form. So we need to complete the squares in the variable of x and in the variable y, and then read off the radius and center from that general equation. Okay, so let's just start by completing squares. But before we complete the square here, pay attention to the coefficients. Here is 4, this one 4, 24, 32, 4. Okay, so as you see, all of these numbers are divisible by 4. So in order to make things much more easier, you can just divide the coefficients by 4, and we will get, so 4x squared, the first term divided by 4 is x squared. Second term becomes y squared minus 24 divided by 4, 6. X plus 8 y minus 1 equals 0. So now here coefficients are much more simpler than the previous one. Okay, now I will just write the x terms next to each other and y terms next to each other. So I will get from this one x squared minus 6x plus y squared plus 8y minus 1 equals 0. Alright, so now here we need to complete the squares, the variable of x. So remember, we need to take this number, divide it by 2, and then square the result, and then add and subtract that number. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9, so I need to add 9 and subtract 9. X squared minus 6x plus 9, and then minus 9. And now here we'll do the same thing for the variable of y. But this time we need to divide 8 by 2, which is going to be 4. 4 squared 16. So we need to add and subtract 16 here. Plus y squared plus 8y plus 16 minus 16. And then we had a negative 1 in the end. Negative 1 equals 0. So here we can rewrite it as x minus 3 squared. Here I will get y plus 4 squared, and then I have these numbers, and now here this negative 9, negative 1 and negative 16 will give us negative 26 equals 0. And now we can take negative 26 to the other side. Y plus 4 squared equals 26. And that's it. This is the general equation of the circle. So center is 3 and negative 4. And what's the radius? Well, radius will be root 26. And that's it. Next question. Question number 4. Find the distance between the center of the circle, this one, and the center of this circle. So you're given two equations. Each one is for a circle, and you're going to find the distance between the center of these two circles. So for example, the first one, I don't know, let's say the first one is over here, so that's circle 1, and the other one, I don't know, it could be over here, and that's S2 with its own center. So this question asks for this distance. What is the distance from this center to the other center? So in order to answer the question, we need to find the center of this circle, and we need to find the center of this circle. As you see, the first circle is easy to find because it's already in a standard form, but the second one is not in a standard form, so we have to go back to the standard form for the second circle. Okay, now let me erase these extra stuff here. Okay, so let's see what is the center of the first circle. Let's call this one circle 1, C1. Let's call this one C2. Okay, so the center of C1, well, it's negative 1 and 1. To find the center of C2, we need to change its equation to standard form. In other words, we have to complete the squares. So let's rewrite it again. 3x squared plus 12x plus 3y squared minus 18y equals 2. Okay, so again, just like the previous example, if you look at the coefficients here, 3, 12, 3, 18, they're all divisible by 3. So let's just divide all the coefficients by 3 to simplify the numbers. The first one becomes x squared plus 4x plus y squared minus 6y equals 2 over 3. Okay, so for the x variable, x squared plus 4x, we need to add 4 and subtract 4. So plus 4 minus 4. And for the variable y, we need to add 9 and subtract 9 equals 2 over 3. And now over here, we'll get x plus 2 squared, and for this one we'll get y minus 3 squared, then minus 13 equals 2 over 3. Let's rewrite it one more time. X plus 2 squared plus y minus 3 squared equals 2 over 3 plus 13, which is equal to 41 over 3. Okay, so now what's the center of this circle? Center of C2 is, well, it's -2 and 3, and that's it. So we found the center of the first one is this number, is this point here. The center of the second one is this point over here, and now we need to find the distance between this point and that point. So we'll use distance formula. So distance is, so I show distance by d. If you remember the formula for distance, d equals what, x2 minus x1 squared plus y2 minus y1 squared. So this is the general formula for distance between 2 points. So in this example, let's call this one x1 y1 and this one x2 y2. So the answer is d equals x2 minus x1. So x2 is -2, -2 minus x1, but x1 is -1. So it becomes +1 squared plus y2 is 3 and y1 is 1. So 3 minus 1 squared equals -2 plus 1 is -1. -1 squared is just 1 plus 3 minus 1 is 2. 2 squared is 4. So the final answer is √5. And that's the distance between the center of the first circle and the center of the second circle.